All right, Unit 1, Section 3 notes for working on writing the equations of functions. Okay, so with these problems, the first thing we want to do is look at our graph and identify, well, what type of equation is that going to give us. So here, since our graph is a line, we know we're going to have a linear equation. Now, there's different ways we could write the equation of a line, but the way that we practiced in our notes the other day was using this form. Y minus y1 equals m times x minus x1. Okay, and then that's an important step because now we just got to fill in a couple of blanks here. We need to know what's y1, what's x1, and what's our slope m, and then we can simplify. Okay, yeah, sometimes we want to use the slope-intercept form, but this equation is easier to work with, so that's what we're going to stick with. Okay, all right, so like I said, we need to find three variables: what's x1, what's y1, and what's m, our slope. Okay, well, x1 and y1 are just the x and y values of a point. Okay, now we have 2 points to choose from. Which one should we use? Well, use whichever one you think is going to be easier. Since these numbers are smaller and they're both positive, in other words, these numbers are a little bit bigger and they have some negatives in there. The negatives can, lead to a mistake. So let's use the smaller positive numbers. So I'm going to call this 1 is going to be x1, and then 2 here is going to be y1. So I'm going to plug this in for x1, plug that in for y1, and then what do we get? We get y minus y1, which is 2, equals my slope, which I'm just going to leave blank for a minute, times x minus x1, which we said was going to be 1. Okay, and then the last thing we need to fill out is our slope. Now, we don't need to solve for that algebraically. We can find the slope by just counting the rise over run. How far do I have to go up and over from this point here to this point here? So from negative 2 to positive 2, I'm going up 4, and then from negative 3 to positive 1, I'm going over 4. So 4 over 4 is my slope, which is just 1. Okay, so then simplifying that, we get y minus 2 equals, well, 1 times x minus 1 is just x minus 1. And then we can add 2 to both sides. And we get y equals x plus 1. And then there's the equation of our line. Now, we would get the same answer here if we used negative 3 and negative 2 for x1 and y1. It would simplify and work out the same. And you can try that if you don't believe me, but it will work. So it doesn't matter which point you use. And then that's how we can find the equation of a line given the graph. Okay. Moving on. Next, we kind of have a special case here. We've got a horizontal line. So hopefully you remember, well, this is either going to be y equals something or x equals something. Those are our vertical and horizontal lines. Then which one's it going to be? Well, what do all of these points have in common? Do they all have the same x value or all have the same y value? And if you have trouble seeing that, well, write a couple points down. Let's do this point right here. That point of over 1 up 2, so that's 1, comma 2. Let's do, how about this point over here? That's back 2 up 2, so negative 2, comma 2. And then, well, what do those two things have in common? Well, for both of those 2 points, y equals 2. So then that's the equation of that line, because no matter how far left or right we go, every point on that line has a y value of 2. If it was a vertical line, it would be x equals whatever the x value of every point on that line would be. And then that's number 2. Okay, so those are our linear functions. Next, we're moving on to some quadratic functions. Now, again, we know it's a quadratic because the graph is that parabola shape. Okay, well, what does the equation of a parabola look like? Well, they're all going to look something like this. Y equals some a value times x minus h squared plus k, which we got to remember that h and k, well, that dictates our shift. In other words, that tells us where our vertex is going to be. Well, since we know our vertex is at 4, negative 3, well, that's giving us our values for h and k. In other words, we know it's going to be y equals some a value times x, something with x in it squared, and then plus or minus some other number. Now, just think about it. To move 4 spaces to the right, how are we going to move 4 spaces to the right? What do we have to have in our equation? Well, we have to have x minus 4 in there. Okay, so we know that's that part of the equation. And then we move down 3. Well, what's going to shift us down 3? Well, having a minus 3 at the end. Okay, and then once we have these things, the last thing we need to figure out is our a value. So we're just going to leave that as a variable right now. Okay, and now this is a lot like the problems that we did the other day. We get our equation if we can just solve for a. So then how can we solve for a? Well, I can solve for a if I know what I can plug in for x and y. So then we can use the other point on our graph, 6 comma negative 1, and I can plug 6 in for x and -1 in for y, and solve for a, and then I'll have my equation. Okay. Now, you might also be able to use the pattern. We'll talk about that in a minute. Okay, but first let's solve algebraically. So if I stick in x is 6 and y is -1, what do we get? -1 equals a times 6 minus 4 squared minus 3. And then that gives us, when we simplify, -1 equals, let's do a little bit of mental math here. 6 minus 4 is 2. 2 squared is 4, so we get 4a minus 3. If we want to get a by itself, so let's add 3 to both sides. And we get 2 equals 4a. So divide both sides by 4, and we get a equals 1/2. Okay, and then now that we know a equals 1/2, we can plug that in here, and we get our equation, which I'm going to write over here where we have some space. We get y equals 1/2 times x minus 4 squared minus 3. And then that's the equation of that parabola. Now, the other way to do this problem, once we know it's the x minus 4 quantity squared minus 3, and all we need to find out is the a, we could look at the pattern. If we go from an x value of 4 to an x value of 6, in other words, if we go over 2, how far up do we normally go? Well, 2 squared, which is 4. But instead of going 4, well, they only went up 2. So 4 times what gives us 2? A 1/2. So if that makes sense, it might be a bit of a shortcut for you. If not, don't worry about it, just solve algebraically. Let's look at another quadratic example over here. Okay, I might start a little bit higher so we don't run out of space here. But on this one, since it's a parabola, again, we know our equation is going to look something like this. It's going to be y equals some a value times something with x in it squared, plus or minus some other number, which we call k. And then since our vertex is at -1, 3, well, let's see, we know it's going to be y equals some a value times something with x in it squared plus or minus some other number. And then how are we going to shift left 1? Well, we got to have x plus 1 in our equation. How are we going to shift up 3? Well, we got to have a plus 3 at the end of our equation. And now we just need to find out what that a value is. I'm just going to leave it blank there, okay, so we can save a little bit of space later on. All right, and then how do we solve for a? Well, I can use this other point here, -4 comma -1, plug in that for my x and that for my y, and then I'll solve my equation for a. All right, so then that's going to be -1 equals some a value times -4 plus 1 squared plus 3. And then we want to simplify that, so we get -1 equals, and then again a little bit of mental math here, -4 plus 1 is -3, -3 squared is +9, so we get 9a plus 3. And then if we subtract 3 from both sides, shorter work here, we get -4 equals 9a. So then divide both sides by 9. And we get a equals -4/9. Okay. All right, and then now that we know what a is, we can plug that into our equation up here, and we get our final equation of y equals -4/9 times x plus 1 quantity squared plus 3. So here's our final equation. Okay, and then always just check your answer. Does that sound right? Yeah, it's negative, and we're opening down, so that's good. And then -4/9, a fraction means it's going to be a little bit wider than normal. Yeah, that looks a little bit wider than normal. Okay, and you can also try to use the pattern. If I go from -1 to -4, I got to go over 3. That means I should be going down 3 squared, which is 9. Well, we only went down 4. So we'll have to multiply 9 by to get 4, -4/9. Okay, so that's a little harder to use the shortcut, but it is there if you need it. All right, next, a linear absolute value function. How do we solve this one? So it's pretty much the same process. First of all, we need to know, well, what's our equation going to look like? And let's use different colors so we don't get confused. Give ourselves a little more space. All right, might have to use all the space here. But how do we do this problem? Well, what's our equation going to look like? Well, it's going to be y equals a times the absolute value of x minus h plus k. All right, and then just like with the parabola, well, h and k are going to tell us where our vertex are, or backwards, our vertex tells us what h and k are. So since our vertex is at 4, 2, in other words, we moved right 4 and up 2, we know our equation is going to have x minus 4 in it and a plus 2 at the end. So it's going to be y equals some a value times x minus 4 plus 2. Okay, and then we just need to solve for our a value, and then we'll have our equation. Now, we can do it the exact same way that we did with the parabolas. We can take our other point, 5, 5, stick in 5 for y and 5 for x, and then solve and simplify, and that will work. Okay, but the absolute value functions are a little bit easier, and since we're tight on space, let's actually use the shortcut on this one. What does my a value represent for an absolute value function? Well, it's just the slope of these two lines. Okay, now one slope is negative, one is positive, so how do we know if it's positive or negative? Well, since our v is opening up, our a value is going to be positive. And then what's the slope between this point and that point? So from a y value of 2 to a y value of 5, we went up 3 and then over 1. So 3 over 1 is the slope. So then that's going to be my a value. And my equation is going to be y equals 3 times the absolute value of x minus 4 plus 2. Let me grab some scratch paper real quick. And let me show you that it would work algebraically as well. We just don't have a lot of room on the notes. Okay, but if I plugged in my x and y value for this point, and I got 5 equals some a value times the absolute value of 5 minus 4 plus 2, well, then we can simplify that. Okay, so let's see, we get 5 equals a times the absolute value of 5 minus 4 is 1, so the absolute value of 1 plus 2. Let's see here. We want to subtract 2 from both sides. So then that gives us 5 minus 2 is 3 equals the absolute value of 1 is 1 times, sorry about that, times a is just a, so we get a equals 3. And then we can plug that in and we get the same equation that we got before. But again, if we just remember that the a value for an absolute value function just represents the slope of these lines, well then it's pretty easy to find our equation. Okay? If you need to work it out, nothing wrong with that either, and it's good to show your work. All right, over here, again, we're a little tight on space. Those other problems took more space. We've got another absolute value function, so then I know my equation is going to look like this. Y equals some a value times the absolute value of x minus h plus k. All right, and then what do we know is going to be in our equation? Well, we know we're going to have y equals. I don't know what my a value is yet. We'll leave that blank. And then, well, since my vertex is at negative 3, 2, I know I got to have x plus 3 to move it left 3. And I know I got to have plus 2 to move it up 2. And then the last thing we need to figure out is what is our a value? Well, that's just asking what is the slope of this line. Well, let's see. Since my v is opening down, I know it's going to be some negative number, so we can throw a negative in there. And then what's the slope from negative 3, 2 to negative 5, 1? Or since we already know it's negative, we can go up if we want to. So from negative 1 to 2, I got to go up 3. And then from negative 5 to negative 3, I got to go over 2. So up 3 over 2, in other words, 3 over 2 is our slope, which is our a value. So then now we have our equation. Okay. Again, we could also plug in negative 5 and 1 for our x and y values and solve algebraically. We just didn't have a lot of space. Okay. And then the last one here, adjust the camera. How do we find the equation of an exponential function? Okay, well, it's pretty much the same way we're going to solve algebraically. And there might be shortcuts, but again, we want to solve algebraically. Okay, so what does the equation of an exponential function look like? Okay, so in general, it's going to look like this. Y equals some letter b raised to the power of x, and it might have, x minus h or x plus h in there, and then plus k. Now again, the h and the k values represent our shift. So how is our function shifted? Okay, well, remember, with exponential functions, normally we go through the point 0, 1. Okay, and then we have some other point that's higher up there. How is this point shifted from 0, 1 to -2, -1? So it's moved left 2 and down 2. So remember, we're not shifting from the origin, we're shifting from 0, 1. So since I moved the left 2 and down 2, well then what do we have to have in our equation? Let's see, we're going to have y equals some base raised to the, well, to move left 2, I got to have x plus 2. And then to move down 2, we got to have a -2 at the end. Okay, so now I've got all that stuff in my equation. Then how do we find b? Well, just like we found a with the other functions. I want to plug in something for x and y and then solve for b. Okay, now again, you might be able to figure it out without having to do this, but this is the best way to do it. So let's go up here. We have a little more space. And then if I use my other point, we don't want to use the bottom point. That's kind of like using the vertex. It just won't work out good, because if I stick in -2, I'm going to get b to the 0, which is always going to be 1. So anyways, we always want to use the higher point up. So we want to use the point -1, 3. So I want to stick in x is -1 and y is 3, which gives me 3 equals some base raised to the -1 plus 2 minus 2. And then we just want to simplify that and solve for b, and we'll have our answer. Okay, well, let's add 2 to both sides of the equation, get rid of that 2. And then that gives us 5 equals b raised to the -1 plus 2, which is b to the first, which is b. So we get b equals 5. And then now that we know what our base is, well, now we can write our equation. So our equation is going to be y equals 5 to the x plus 2 minus 2. Okay. All right, so there's our equation. One more to go on this page. Okay, and then the last one. How do we find the equation of this function? Okay, well, same thing. We're going to figure out first what our equation is going to look like. It's going to look something like this. Y equals some base raised to the x minus h plus k. And then let's see, how is this thing shifted? So from 0, 1, they went over 3 and up 2. I'm sorry, over 3 and up 1. So how do we move over to the right 3 and up 1? Well, then to move right 3, we got to have x minus 3 in our equation. To move up 1, we got to have plus 1 in our equation. So our equation is going to look something like this. Y equals b raised to the x minus 3 plus 1. Okay, next, how do we solve for b? Well, let's plug something in for x and y, and then we can solve algebraically. So if I can stick in x is 5 and y is 26, we can solve for b. So then we get 26 equals b raised to the 5 minus 3 plus 1. Okay, let's start by subtracting 1 from both sides. And we get 25 equals b to the 5 minus 3, so b squared. And then, well, let's just think, what squared is 25? Well, 5. So then, again, we get b equals 5. And now we can stick that in here, and we'll have our equation, which is going to be y equals 5 raised to the x minus 3 plus 1. Not a ton of space there, but it fits. All right, and then next we'll start the second page.